Hey guys, welcome to my YouTube channel. In this video, let's learn how to implement rectified linear activation function ReLU using Python Numpy. So this is the most widely used activation function. So let's look into the function. So here let's take the values that is between the negative to positive range. Let's take -10, -5, 0, +5 and +10. So what this function does is, that is f of x. So if the value of x is 0 or less than 0, so it converts it to a 0. So this is less than 0, convert this to a 0. So this is also 0, 0. So here it remains as same, that is f of x equals to x, that is a 5, and here f of x equals to the x itself. So this is the rectified linear activation function where it converts the values of x where x is less than 0 to 0, and whatever the x value, so it remains the same, that is positive values. So let's look into the function. So here is a function that is f of x equals to max of 0 comma x. This can also be said as f of x equals to x if it is x is greater than 0, else f of x equals to 0, so if x is less than 0. Yeah, so this is the function of rectified linear activation function in neural network. So let's try to implement this using Python. So let me remove this image and let's try to implement the function. Yeah, so let me remove these as well. So here let's take the required libraries, that is matplotlib and numpy. So let me import matplotlib dot pyplot. Yeah, let's import as plot, and I need the numpy. Let's import numpy as np. Yeah, so these are the two required libraries that I'll be using. So now let's take the values of x equals to, that is numpy dot array, that is a range. I'll be taking a floating point range that is from between -10 to +10, and I'll be giving the step as 0.05. So this is my step. So this is the function that will generate a floating point ranges using numpy. And now I have to take y values, that is y equals to, I have to use the rectified linear activation function. So to use that, let's use np.maximum, that is maximum between 0.0 and the value of x. So this will give us the rectified activation function. So we get the values of y given the value of x. So now let's plot it using matplotlib plot dot let's say plot, and let me give the value of x and y over here. And yeah, so in order to see the plot, let's say plt.show. Yeah, so this is the function I'll be using. Yeah, so this is the complete implementation of rectified linear activation function ReLU. So let me run this program and let's see how it works. Running the program, so I think it will take time. Yeah, so here is the graph. So you can see that this is the rectified linear activation function for given the x values that are less than 0. So it'll say that y values are 0 for that is minus 10 to 0, that is x values are set to be 0 over here, that is y value is set to be 0. So for the positive values, that is from 0 to plus 10, so you can see the graph, that is from whatever the x value, the y value remains same, that is for 10, you can see that the graph is pointing towards the 10. Yeah, so this is the ReLU function implementation using Python Numpy and matplotlib. Closing this graph. Yeah, so this is the implementation of ReLU. So that's it in this video. Hope you liked it. Thank you for watching. Bye.